Hello and welcome. So today we are going to look at the cross validation. So the first question is that why why we need the cross validation, right? So so the point is that so how we can make the decision that that uh, which model will work for most of the cases or most of the scenario. So there should be some measure that we should be able to quantify that uh, this model is going to work uh, more better than the model, some other model, right? So we need to have some kind of measure that we should be able to differentiate between, like given the data that that a particular model should work with uh, maybe with if we have some kind of variation in the data, then that particular model should have the uh, capability that it should work, right? The point is that you want to have the model that should be more robust, right? So how we are going to decide that? So what we do is the cross validations, right? And with the help of this cross validation, we select such kind of model. After doing this cross validation, we select a good trade off, a model that represents a good trade off between the bias and the variance, right? So because even we cannot select the model with the very high variance, right? Because if we go for the high variance, then we will lose the bias, right? And if we go for the bias, then we will lose the variance, right? So we should have something that should that give us some kind of measure, and that from that we should be able to select a model that should be a good trade-off between this bias and variance, right? So that is what I have written here, that how can we automatically select a model that represents a good trade-off between bias and variance. And if you have no idea about this bias and variance, then first you will have to some kind of idea that what is this bias and variance in terms of this machine learning, right? Then you will be able to understand that why we need to have this cross validation, right? So if you haven't gone through this bias and variation, then I would recommend first you should go through this bias and variance, then you can jump onto this part, right? So it is all about the model selection, and that model should have the good represent that should be good trade-off between the bias and variance that model should have, right? So that's what we are going to do. Let's assume that we have some finite sets of model, right? And that, let's suppose that this is your first model, right? And so you have given some kind of data, right, data set, right? And you want to select a model that that should be a good trade-off between the bias and variance, right? And what you are going to do, you are going to maybe fit with the linear line, or maybe you are going to fit with the higher polynomial that, and you are going to maybe fit with the locally weighted regression or the linear regression like this, and maybe you are going to fit with the support vector machine, right? So let's suppose that you have some d set of models, right? So you can call this model 1, this model 2, and this model 3, and this model 4, and this model 5, and so on, that you have the set of models up to md, right? D sets of model, right? And let's suppose that you have the trainee set S. So what do I mean by trainee set S? That you have some data, and that we are calling it as a trainee set S, right? So the very that initial thought would come up in your mind, that let's train your model using this complete set of data, right? You can use this complete set of data, and you can make you can make use of the complete data to train your model, right? And let's suppose you trained your model this m1, this m2, this m3, and each of this model is going to give you some hypothesis function, right? So let's suppose that call this h1, and you can call this h2, and you can call this h3, right? So at the end you will have to make the decision, right, out of these three models which model you are going to change. So the basic thing you can do is that you can run your you can train your model throughout your data set, right? So let's suppose you have 1,000 number of data training example in your set, and then based on that 1,000 data examples you are going to you are going to train this h1, this h2, and this h3. And at the end what you are going to do is you are going to look at the how much error I am getting with this h1 in h1, in h2, and in h3. And then you will make the decision that let's suppose with h2 I am getting less error, so you will select your model m2, right? Now it has some problem. I will let you know that what the problem is. So what you have done, so you have trainee set s, and in this set you have the data, right? So train each model, so train each model mi, so you trained each model, right? So all this 1 2 3 4 and whatever you have on this trainee set s. So let you have some training examples that we are calling it as the training set to get some hypothesis function hi, and you got this corresponding hypothesis functions, right? Now you pick the hypothesis function with the smallest training error, right? So let me just give you an example. Like let's suppose you have some set of linear, and you have some set of model that is of some kind of polynomial, right? So you, let's suppose that you have these three models you have trained with these three model, that above three, that polynomial one. So in first model with the data set, with the given data set, you have trained your model like this. The first training is this h1, this model, and the second model is maybe some kind of like this, and the third one is, so same training example, maybe like this, right, with higher degree polynomial. So what you have done is now you are going to calculate this error, right, with the first model, how much error you are going to get with the second model and the third model. So pick the hypothesis with the smallest training error, and but how you will make the decision that whatever hypothesis function will have this smallest training error that you are going to pick, right? But this is not a good idea, so it will not work, right? Why? So it is going to choose, so what will happen that let's suppose that we have selected these three, right? So so we have selected these three models, right? So this higher order polynomial is going to fit into your data, right? So you have this training example, then this higher degree polynomial is going to completely fit into your data, right? And in this case what will happen that you will have uh, almost no error between your predicted value and between your actual output, right? So you are going to get no error with this higher degree polynomial, right? So what, so the problem is that the higher the order of the polynomial, the better it will fit into the trainee set, right? Suppose let's suppose you have this, so so let's suppose that you have polynomial hypothesis polynomial have a degree 1, so this will be a straight line. And let's suppose that you have some cubic polynomial, then for the same training example the hypothesis will fit like this, right? So you see that it has some kind of some error, but this have no error, the data point. So so how you are going to select is, so you will look at the smallest training error. So you will look and you will see that it has the smallest training error, then you will going to select this. But but it is not going to work, because uh, because because this even this is not a good predictor, right? It is not a good predictor, right? uh, so so why it is not a good predictor? Because you see that around the data point you have a lot of variation, right? So so overall point is this is not going to be a good predictor in comparison to this, right? So if you, on if you do this kind of analysis, and you are going to, what is going to happen, that you will always be selecting the uh, higher model with the higher variance, right? So this method will always select a higher variance and high degree polynomial, right? So I hope that you got the idea that why it will not work. Okay, now what we can do is, so in this example what we were doing is that uh, we are taking all the trainee set, right? All the example of trainee set, and based on that we are fitting our uh, parameters, or ultimately we are getting the hypothesis function based on the complete training example. Now to improve this, what we can do is we can use this hold out cross validation, or you can simply say the simple cross validation. And in this method what we are going to do is we are going to randomly split uh, the training example into two. And first we are going to call this the S train, and this second set we will call the SCV. That means the that hold out cross validation set, and this is trainee set. So what we are going to do, that we, let's suppose we split our our trainee set S into two parts, and one part what we are calling is the one part that we are going to train on that part, that with the 70 part, and we are calling it the S train. And the remaining 30% part, what we are going to do, we are going to validate, right? We are going to test our model on this 30%, right? So we have splitted our complete example, training example, into two part. And with this 70% part we are going to train our model, and with this 30% part we are going to validate our model, right? So what we are going to do is the train each model mi on S train. So we are not going to uh, conduct, or we are not going to train our model with the complete data set like earlier we have done. No, we will have some randomly chosen 70% data from our training example, and on this 70% data we are going to train our model. And for each model we are going to get the hypothesis, right? So for each model we will have some hypothesis, and that has been trained by this 70% example, right? Now select and output the hypothesis hi that has the smallest error on the holdout this CV set, that cross validation set. So now what we are going to do, so on this 70% we are going to train our model, and on this 30% we are going to test our model. And in this, so we will have the all these h1 h2, right? H1 hypothesis and h2 hypothesis and h3, all these hypotheses. And we are going to test this with the 30% data, and with this and with this also. So ultimately we will have the error, right, for each one. And we are going to select that model which have the lowest smallest error, right, on this cross validation set. So what we are doing here is training on this 70%, and validating our model on this 30%, right? So why we are doing that? Because during the in this example, in this algorithm, the issue was that model that model was trained on this complete set, and model have the information of all these data set. And during the test time, what we are doing is that we are, so even if you pick any data from this training set to test your model, it is going to be good, right? Because this model has itself trained on this complete set, right? And here what what is uh, more advantage is that that models have trained on this 70% data, and this 30% data have not seen yet during the training phase, right? So this 30% data model haven't seen. The model have trained on this 70% data. So what we are going to test is what that that few data that have been not seen yet by this model, how it is going to react on this unseen data, right? So it will be more, I can say that you will have the more information about this, the variance of this model in this algorithm, right? So 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 we can test on this 30% unseen data, and we can note this error, and whatever have the smallest error, we are going to pick that model, right? And it has a disadvantage, right? Because we are wasting 30% of data, right? So to carry out this kind of cross validation, if we have the huge data, or I can say the cheap data, where we do not worry about the, so the point is that if we have the huge data, then we can split that data into 70% and 30%, and we can conduct this cross validation. There is no issue with that. But what happens that, let's suppose you have that only 20 examples in your training data set, right? So you so that so so you will not, like, so to train your data, if you if you take the 70% of this, you will left with only few data example, right, to train your model. So if we have the huge data set example of data, then obviously this is going to be work perfectly. But there would be issue if we have the less number of data set, right? So let's suppose we have the only 20 examples. uh, then how we are going to do? So we would like to do something better, right? So we cannot go using this approach. We can go, but that okay. So now we can do something better. Let's see what we can do. So now where it came, the k-fold cross validation. This k-fold cross validation. Okay, let's try to understand this. So let me first tell you that how this algorithm works. So what we do is we randomly split the training examples, right? I will describe you each step, that how it works, right? The first point is that we are going to randomly split the complete data set into k disjoint subset, right? So let's suppose that we have 6 examples in your S set. So if S set means you have 6 training example, first to 1 2 3 4 5, like that. And let's suppose that you split this example into 3 groups, maybe with the 2 2 set, right? Because you have complete 6 examples. Then if I ask you that split into k disjoint subset, then how you are going to split is, let's suppose I told you that split this into 2 2 group. So each each subset will contain the 2 example, right? And the complete example is the total example is 6, right? and and what we can call is that, let's call it that subset 1, subset 2, subset 3. So this is the first step, and in second step what we are going to do is for each model. So we have, let's suppose we have this for this model, right? For each model, so we pick our first model. Let's suppose I is equal to 1. So we pick the first model, and what we did, so this is the outer for loop. We pick the first model, and now in the inner for loop we are iterating through 1 to k. And what is k? This is the number of the groups or number of the subsets, you can say. So we are in the first subset, and we are in the we have taken the first training example, first model, that MIM1, right? Now what we are going to do is train the model M1 on, so train the model on each of these subset, and keep one and skip one subset. So what we are going to, what do I mean to say, that train your model on the first iteration, train your model in S1 and S2 and skip this S3. Or you can say, if you want to go through this algorithm, then step by step what we can do, that skip this S1 and train your model in on S2 and S3. This is what I have written. So train your model M1, train your first model on this subset 1, subset 2, and subset j minus 1 and subset j plus 1. And if you look here in this algorithm, what we have skipped is the sj, right? Because after sj minus 1, j plus 1 is there, so obviously sj is missed here, right? So here, if you look at this, what we have done is we have trained our model in S2 and S3 subset, and we have skipped this S1, right? So we have trained our model on this. Now we are still in the same inner for loop, and what we are going to do, whatever we have left Sj, we are going to test the hypothesis. So we trained the model and we got the some h1 hypothesis, and we are going to test our model on this left, whatever we left s1, we are going to test on this, and after testing this we are going to get some error, right? Error, I mean to say, some how much variation with the prediction value and the output, right? So we are going to some error, and again what we are going to do is, again we are going to iterate. So this j will go from, for this particular example, j will go from 1 to 3, right? So it will take the 3 iteration, right? So now what we are going to do is, we are going to, in next iteration, what we are going to pick is the s1 and s3, and we are going to skip the s2. So we are going to train our model on this s1 and s3, and we are going to test this on s2, right? Same like we are going to, in the next iteration, we are going to pick that s2 and s3, s1 and s3, sorry. So we are going to pick now s3 and s1, or s1 or s3. So we have done that, right? Now we are going to pick this, so s3, so s1 and s2 we are going to pick and skip this s3, right? And we are going to test this on s3, and we are so we will have the error for each, right, for each hypothesis, right? And so right, and now, so this what we have done is for the model m1, right? Now this this I will get incremented, and uh, we will uh, we will pick our second model, and we are going to do the same thing for this our second model, right? And at the end we will have this error, right? All from all those hypothesis function we will have the error, and at the end what we are going to do, we are going to average those error, and we will see that which have the smallest error, where we are going to pick that model. Okay, let me explain you more briefly that how we are going through, right? So at the third state, we're going to pick the model mi with the lowest estimated generalization error. So okay, so let me iterate through the ACE exam. So let's suppose that this is your training example, and you see that how many example do you have. You have 1 2 3 4 5 6. So this your training set S contains the six example, right? And what I am saying that let's split this into three groups, and you see that we have randomly splitted this training example into first, second, and this three, right? And what I am saying that this one and this data belongs to this group, so that is what here they are. And this data and this data belongs to this group 2, and the sorry and this data and this data belongs to group 3, right? So we have separated, so we have formed our group. Now 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 what I told you, that you are going to skip one group, right? Let's suppose that you are going to perform the test on this group, and you are going to train your model on this group 2 and group 3, right? So if you merge this group 2 and group 3, then this is how your training example will look like, right? So this is the data point, and this one is here, and this one is here, and this one is here, right? So on this example, what we are going to do, we are going to have trained our model. So after training our model, you are going to get a hypothesis function. So this is the black one, a straight line that you are going to get, right? And we have left this group 1, and this group 1, you see that this is the data point and this is the data point, right? What we are doing is we are looking for the error. See that this height, and we have noted down this error, right? So we are still in m is equals to 1, so I is equals to 1, and this is the first iteration that we have done, right? So this is you can say here j is equal to 1, so j is equal to 1. Now what we are going to do, we are going to take this to group 2 and group 3, sorry, group 1 and group 3, group 1 and group 3. So this will be our training example. We will use this two group to model our to train our model, right? So these 4 data points are there, and we are going to use this group 2 for the testing, right? And you see again, what we have done is, using group 1 and group 3, we have trained our model, and we have got this black hypothesis function. And here what we are noting is the error. We are looking at this error on this group 2. You see that here we have some different hypothesis, right? And we have some slight change in our hypothesis, right? And so this is for j is equals to 2, right? So this loop is going to run for the 3 times, right? So now what we are going to do, that we are going to pick this group 1 and group 2 for our training the model, and group 3 for testing, right? So again we are going to get this some hypothesis function, and and we have done the test and we looked for the error and we have noted down the error. So this is for the first model. Now let's suppose that let's suppose that we have two models that we are comparing, right? So similar thing we are going to do with the second model, right? Let's suppose now we have the second model that is some higher degree polynomial. So you see that here we have different kind of it with the higher degree polynomial, right? And here we are going to do the same thing, right? What we are going to do, we are go split so we have already splitted data into three groups, right? So we are going to again pick this group 2 and group 3 to train our model, and on this group 1 we are going to test our model. So this is what we have done, similar thing, uh, but now we have this some other hypothesis, some higher degree polynomial hypothesis. So we have picked our data to from group 2 and group 3 to train our model, and we got this some higher degree polynomial, and we have tested it and we have noted down the error. Similar, we have picked, so again for m is equals to 2, j is equals to 1, the first iteration, and j is equals to 2, j is equals to 3. So we pick the group 1 and group 3, group 1 and group 3 to train our model, and group 2 to test our model. Group 1 and group 2 to train our model, and group 3 to uh, test our model, and we have tracked the error, right? Now you see that here what we are going to calculate is, so we have this complete error with the straight line and with the higher degree polynomial, right? So we are going to take the average of this error, and we are going to take the average of this error. Now at the end we are going to pick the model which had the smallest error, right? So I hope you understand that what is this uh, k-fold cross validation. The point is that we will split our data into k subset, and we will pick from those uh, total groups. Pick we will skip one group, and we will pick all other groups, and we will skip one group, and whatever group we have skipped we are going to perform the test using that skipped group, and whatever we have picked apart from that one group, we are going to train our model on that apart from that one group, right? And 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 again, so let's suppose, so let's suppose that you have you if you splitted your complete data set into 10 group, right? So what you are going to do, you are going to pick this 10th number group for your test, and these 9 group for your uh, training your model, right? And that is the one thing. And again what you are going to do is that you will have the same set. Next time, in next iteration, what you are going to do is you are going to, sorry, 8 9 10. So now next time you will pick this as a for the this group for the test, and all this group for the for modeling your for training your model, right? So this is what we have done, right? We have splitted. So overall point is that you are going to make use of each group to test your model, right? So next time you will pick this 8 to test your model, and apart from whatever you have left with, you will train your model, right? So this is what you see. If you look this, then this is what I have done, right? We have total 6 training examples, and and we have tested for each combination, right? And also we have modeled our trainee model. So also we have uh, trained our model using each example, right? So I hope that is making sense to you now, that what is this k-fold cross validation. Okay, that was all I think. And very commonly used choice for k is 10. So basically we grouped our data set into k folds, right? So we will have the 10 subset of our training examples. And if you do that, k, if you pick k is equals to m, that means each training example, right? So if k is equals to m, what does it mean? So you have divided your complete data set into single training example. So this so the point is that what you are going to do, you are going to, so suppose you have 100, suppose you have 100 suppose you have 100 examples in your set S. And what you have done is you made the group with like 1 1 1 1 1 1 and 100 times 1, and each group contains only one example. And what you are going to do is, in the first iteration you will pick the 99 uh, data, and train your model, and you are going to test on this left out one example. Again, next time you are going to uh, use this, the one example to test your data, and all other 99 examples to train your model, right? So the diff, if you take this k is equals to m, what does it mean? That that you are testing your model with only one example, right? And you are training your model with, if m is the number, total number of example, then you are training your model with m minus 1 uh, examples, right? So that is what we call the leave one out cross validation. So leave one out. So out of this complete example, leave one and train your model and test your model whatever you left. So that is how it's going to work in the extreme cases. So that was all in the cross validation. So thank you.